It looks like we have
Can
some
you
slides up there.
to see if you can choose?
Able to use the share
Looks like-
preloaded
Yeah,
function.
or Ben, could you? And did you see the main slides there too?
For some reason, it's not listed under meeting materials, but if you
Okay.
one of the 5 power buttons.
Yeah, we're trying to do it, but since you're sharing, we can't see what it is.
Okay, I'll take that down so you can check it.
Just to try. Yeah. All right. Just one of you want to give us permission to try, or do you see it, Chris?
No, I'm waiting for one of the chairs to approve your request.
Yep, same.
All right, now where did
I
that
don't
request?
see a request. Oh, I see a grant.
Yep, cool.
Grant.
Oh, there it is. Okay.
Yep, I see it. Technical slides. Got it. All right, I'll
Awesome.
stop sharing now, but looks good.
All right, Ben, you want to kick us off?
Well, okay. Let's see. It's is there a clock in here somewhere? Well, it's only 1 minute after the hour, so I think we can give folks a little bit more time to come in. We're going to continue mentioning that we will need an official minute taker before we can start the session. Minute takers are only required to note relevant and important points from the discussion. Full transcript is not required or expected.
Quick question, Ben.
Yeah?
Is this recorded? It does say recording. Just making sure that it is.
Recorded. I don't know that we have any control over the recording.
Well, it says it's being recorded, which I think is a good thing.
Yeah.
I'm not getting against it, but I want to make sure that it is being recorded and made available because I'm looking at the number of participants and it's 17.
Yes.
And it'll be good
Thanks
for others to have.
Thanks for reminding
video.
us of that, Jana. Yes, so another reason that being a minute taker is not terribly difficult is that the full contents of the meeting are actually being recorded. So the only thing we're asking for a minute taker to write down are the substantive conclusions reached by the working group in the course of discussion. Anybody who wants the full details can always go directly to the recording. Okay, I think that that people have more or less finished trickling in. So I want to remind everybody that this is an IETF session. It is covered by the IETF Note Well. That covers both things like patents and IPR related to any discussions or activity in the working group, and to the Code of Conduct, which requires us all to be professional and respectful in our communications here. I'll avoid trying to summarize the full details of the IETF Note Well, but if you're not familiar with it, please do familiarize yourself with it before participating in the working group. As mentioned, we do need a minute taker before we can begin the discussion in earnest. So if anybody would like to volunteer to record some minutes, please do let us know. The note-taking tool is right up on the top of your MeetEcho screen. It's the fourth button from the left at the very top, I believe. So it's very easy to jump in and make some notes. We would appreciate it.
Jabber, Matthew Finkel.
Okay.
Take notes.
Thank you very much. Thank you to Matthew Finkel for volunteering to take some notes. Anybody else who has a moment to help out is welcome to do so in the collaborative note-taking tool. If you do need to go to the microphone and don't want to or are technically unable to use the voice features in MeetEcho, please just type your question into the chat with a request for it to be brought to the microphone, and one of the chairs will handle that for you. And when you are coming to the microphone, please help out Matthew Finkel by stating your name so that we know who is speaking. Let's get started. This is our proposed agenda. We have 90 minutes for this session. We have 3 presentations. I think in each case, we will try to take only clarifying questions during the presentation, and then have a few minutes for a more general discussion before coming back to the next set of slides. And finally, an open discussion after all of these presentations to consider how we should take action as a group based on the new proposals and changes that have been brought before the working group. I think we're ready to get started with our first presentation. So I'm going to turn my slides off and approve Chris Wood for slides. Chris Wood and Jana Iyengar, it's all yours.
All right, thanks. So I'm going to talk, I guess, about half of the architecture, and I'm going to hand it over to John to do the rest. So there's going to be an awkward split in the middle, so apologies for that, but we can work through it. Okay, anyways, so this whole set of presentations is the result of a couple of us going back to the drawing board and looking at, what is the state of Privacy Pass in terms of the architecture, in terms of the protocols, and how can we sort of move it forward to something that's, feasible to implement, feasible to deploy, while still satisfying the use cases in the charter, and all the, the existing like W3C considerations and whatnot. And upon like revisiting the architecture, we found that it didn't quite capture the intent of the overall desired ecosystem. And we're going to kind of lead you through our thought process that led to this new proposal of the architecture document. And so hopefully at the end of this, it becomes clear why this new reframing of the architecture is, I think, more appropriate given the scope of this particular group and what we're here to achieve. So with that said, let's jump in. I'm going to motivate the architecture by just reminding everyone sort of what the interaction for Privacy Pass is right now. So let's say you have a client and a server who are interacting with one another. The client is specifically talking to the server or interacting with the server to get some particular resource on the web, say an image in this particular case. But the server, upon getting this request from the client, decides to challenge the client because it looks suspicious. It comes from an IP address that it doesn't trust or has a poor reputation. As was the case with Tor, the original motivating use case for Privacy Pass, or whatever other reasons the server might have to challenge the client. The client, upon getting this challenge, will solve it, for some definition of solve. and generate a proof based on the challenge. And I'm sort of generically using the word proof here to just talk about, something that was done to satisfy the challenge that the server just sent and sends along to the server. And if the server's happy with this, as in, that the proof checks out for that corresponding challenge, the server happily does whatever, the client requested. In this particular case, getting the picture of the dog. The interesting piece of Privacy Pass is really this middle section, this challenge and proof interaction. Now, if you go back to, again, the original motivating use case for Privacy Pass, it was that the challenge was expressed in terms of a CAPTCHA. Can you solve this CAPTCHA? That was what the question that the server asked the client. And the client would, engage the user to solve the CAPTCHA, click on buses, sidewalks, whatever. And then the solution to the CAPTCHA, which was the proof, was sent from the client to the server. And the server would just check that, it was valid for that particular instance of the CAPTCHA. But there's really nothing that says that the actual proof that the client sends has to be a solution to a CAPTCHA. And this was the key insight of Privacy Pass. Rather, it could be proof that the client had previously solved the CAPTCHA. Like, I interacted with the server before, I got some proof at that point in time that I solved a particular CAPTCHA. And so at some point in the future, if I get challenged again, I just represent that proof to the server. Or not present that proof to the server. And if the server trusts the particular proof, everything checks out. But you can generalize this a bit more. It doesn't have to be a CAPTCHA that the server asks the client to solve. It can be, any type of property that the server wishes the client to attest to. So CAPTCHA is just one example of that. It could also be, do you have a valid account for this particular application? Do you have a valid device that you're using to access this particular resource? And any combination of properties, really, that makes sense for the server's particular application. And the client, upon getting asked to attest to these particular properties or this particular property, can present that proof to the server, and the server can check it based on, whatever, and then do whatever the client wants. So let's now sort of break down what happens when a client attests to some particular property and then presents a proof to the server. Let's imagine there was a separate function for that the client interacted with for attesting to a particular property, and then kind of getting proof that it did this attestation. So in the interaction before, the server would challenge the client to attest to some particular property. Client would then go talk to what we call an issuer. It would do the attestation with the issuer. And then the issuer would present proof of attestation. The client would then relay right along happily to the server. And if the server trusts this particular function, this issuance function, then this is indistinguishable from the case we had before, where the server was like the one doing the attestation and generating the proof and then checking the proof later on. You have this trust relationship between server and the issuance functionality. The resulting system is effectively the same. But we can decompose this even further. Imagine now you took the attestation piece of this and you made it explicit and pulled it out of the issuer. And so in the interaction that we had before, the server would challenge the client to attest to some property. The client would do this attestation to some attester. The attester then would, on behalf of the client, ask for a proof. And the issuer, assuming that it trusts this particular attester, would generate proof. The attester would forward that proof to the client, and then the client would present that proof to the server. And so now the trust relationship sort of looks like this. The server trusts the issuer to generate proofs. The issuer trusts the particular attester to do attestation of the client. And then this arrangement, we argue, is basically the same as the original interaction where everything was collapsed together. And indeed, that's what the Privacy Pass architecture was written, or that's the way it was written. It was written such that everything in red was the same box. It was referred to generically as an issuer. But really, we can split out these functionalities into separate functions. It's separate functions that exist on the same box, or separate functions that are run by separate members of the ecosystem. And that's the new sort of reframing that we're proposing for the architecture document. And with that said, I'm going to now do the awkward transition over to Jana to describe more about the different variants of this. So I'm going to stop sharing and then be quiet.
Thanks, Chris. Well, I was going to ask you if you could just continue sharing, but that's.
I could, but it's probably easier.
No, that's fine. All good. Yeah. All right. Can we get to slide 14? Okay, there we are. Okay, end of awkward transition. Thank you, Chris. We made it as awkward as possible. Hopefully that woke you up from your, well, whatever time zone you are in. So continuing where Chris left off, basically, the important idea here, and this speaks also the question that's NPD is asking on Jabber. The idea here is that separating these functions, and we want you to think about these as functions that are part of the architecture anyway. Separating them out gives us degrees of freedom. Now, of course, the degrees of freedom are useless if we can't do something with them, and we'll talk about that later. But this allows us to instantiate multiple different variants, so to speak, or instantiations of Privacy Pass. Bear in mind that we don't need them all to be separate entities. Like, for example, in the existing Privacy Pass architecture, you could think of the issuer as the architecture as the first one, which is like a combined origin, attester, and issuer, where everything is the same entity. The client speaks to the origin, and the origin also happens to be the attester and the issuer at the same time. So that is one instantiation of this architecture that is possible. You can also have a second instantiation where you have separate origin and a combined issuer / attester, where the client speaks to the origin and then gets a challenge and then goes off to this other entity, which is the attester plus issuer, and gets this. Gets the proof that it takes back to the origin, and finally all separate entities as well. This is separate, again, separating of the architecture. Yes, it does make it seem a bit more complex, but it does give us benefits because we are able to do some things here that we can't otherwise do, and we'll get to that in the details. But I'm going to talk about just architecture at the moment. NPD, again, we will get to that. Especially the rate limiting document speaks to the all separate case, because that is one instantiation of the architecture that you need to be able to do rate limiting anonymously for clients. So you will see that in the rate limited example. But generally speaking, we believe that the separation allows us to build more use cases within Privacy Pass. So the protocol structure for this architecture is split into two, and these are described in the architecture document. The first one is the redemption protocol. Then the redemption protocol is simply where the client is able to redeem proof with the origin, and this is a consistent protocol for all of the use cases that we can do with this. That's the goal, is to sort of have one redemption protocol, no matter what the use case, so that the client origin interaction remains exactly the same. The extensibility in this architecture comes from being able to have multiple issuance protocols, because the issuance protocol effectively says, hey, I'm going to issue you a proof for a particular property that the client has to attest to. And that defines the issuance protocol to some extent, and the particular details of that would depend on the use case. So for different use cases, we might have different types of issuance protocols, and this is an exchange that we can extend. We can replace it for new deployment models. So again, the idea here is to keep the redemption protocol the same for all use cases, but have different issuance protocols for different use cases. Stepping back, the big picture here is that the architecture now, the new proposed architecture at least, argues that some function attests to a property that is associated with a client, such as a captcha or something else. The issuers are the ones that that look at what the attester is attesting to, and then they produce a proof or a token that is bound to that property, and the redeemer then consumes this token, right? Or the origin consumes this token that is generated by the issuer. So those are the functionally those are the pieces that we believe are part of the architecture here. So to the question of why do we want to rework the architecture, I've said this in other words already, but generally speaking, the high-level picture here is that the current architecture tightly couples these two pieces that we're trying to separate out. And separating the issuance and the redemption parts allows us to have new deployment models that are possible now, and that we'd like to be able to build to, but are not really possible with the existing privacy pass architecture. The new issue, as I said, the new architecture leaves redemption unchanged, leaves redemption as it is for not redemption as it is, but creates a redemption protocol that remains the same for various use cases, but you deal with them by changing the issuance protocol. This makes attestation explicit as an architectural piece, but it is only, it is explicit as a instantiation, as an entity only in particular deployments, not in all. Depending on your deployment, you might want to instantiate it separately or combine it, as I showed earlier. So finally, our proposal here is to define the architecture in terms of these functional roles. The flexibility that this offers obviously comes with some complexity in understanding the different roles, but really we believe that it is separating these roles. They were hidden anyway, and the degree of freedom that it offers us allows us to express some use cases in privacy pass that we weren't able to. And it defines the protocols in terms of the redemption and the issuance protocols. And we have a PR here that describes this architectural change that we'd like to merge into the architecture document. That's all I've got, Chefs. Do you want to do questions now? We got 5 more minutes left in the presentation.
Yeah, this would be a good time for any questions about the draft. About this proposed change to the draft.
Chris should come up to the mic. Ben, you're up.
So hi, not as chair. In these diagrams, you have 4 entities and 3 communication links. Which of these links are standardized or standards relevant, and which of them are essentially by private agreement?
So the hard, I'm going to answer, and maybe Tommy, you can jump in. The protocols are standards. They're all standardized. Like, I mean, all of these 3 entities are effectively can be separate, completely separate organizations, and therefore the protocols between them will need to be standardized. And that's in the different protocol documents that we have. Tommy, do you want to add something?
Sure. Okay. Yeah, I think the answer is a little nuanced. So then I would say, the connection between the client and the server, I think, should be really standardized, and I'll be talking about kind of that challenge phase. I think that's kind of the most important to be very general, because we're imagining that this is mainly a client talking to a web server or some other server that it doesn't have a prior relationship with, because otherwise it wouldn't need anonymous attestation validity. So that one I think needs to be completely standardized. On the other side, I think it gets a little bit more flexible depending on the situation. So, I would argue that even in the existing architecture, the actual attestation step of solving the CAPTCHA, that part itself was not standardized. The thing that the client does to the attester to say, I am legitimate, even if it is standardized, I don't think that's something that's within scope for Privacy Pass itself. We're not defining how you do CAPTCHA. We're not defining how you do device attestation or account login or whatever else it is. So there's kind of like some step in there that is unique to how the client talks to the thing that lets it get tokens. And that is specifically not standardized in this group. But as we will go into in the third presentation around issuance protocols, the way you actually get a token, that needs to be standardized. And that's what already existed for the issuance protocols, saying, hey, here's how you use a POPRF, or here's how you need to get a publicly verifiable token. And so there's a bit of standardization on the issuance protocol, but I think it's expected that no matter how you deploy it, with the tester and issuer combined or separated, there is some bit of like additional things that need to be added to the exchange that are not in the base Privacy Pass spec that actually prove that this is a legitimate client. Does that make sense?
That's certainly helpful. Thanks. Let's move on to the next presentation.
All right. Was my audio still choppy? I saw that in the Jabber.
It seems to have improved.
Okay, that's great. All right. So now we're going to go into the two halves of the protocol that we talked about. And I'm going to start by talking about this challenge and redemption phase. Oh, and could the chairs restart the timer, actually? So I'm getting the red flashing lights that I'm almost done. Great. All right, so going back to that diagram, this is just focusing on what is this interaction between a client and what I'm calling an origin here, because I'm thinking of this in the web server context, but this could be any server that the client talks to that it wants to be able to provide anonymous tokens towards. And as we were just talking about with Ben, I think this is the key part to be nicely standardized, nicely extensible, because this is the case where you're talking to someone who you don't have a previous trust relationship with. And as I had in the title here, there are two halves of this that we think of, and we're calling it challenge and redemption. And the broad shapes, not talking about any particular protocol here, is that in a challenge, the client is telling some server, hey, I want to do or access something. And the origin is like, prove that you're able to access this. Give me a token to prove that you're not a bot or to prove that you have an account or something. And then the redemption phase is when the client comes back and says, hey, I do have a token or proof or whatever it is. And the origin says, great, go ahead if that works, or it says, no, that was not enough. And not the both of these are not always required. So the redemption half, no matter how you slice things, I think is a fundamental part of any token scheme we have. We actually need to spend the token. And so the token redemption is whenever the client presents a token to gain access, and within Privacy Pass, these tokens are anonymous. But they are essentially an anonymous way to say, I did something and I got this token issued to me. You should trust me. And then the challenge half is optional, but often is useful. And some of the things that the challenge adds as value is that it allows the server to indicate in the first place that it supports tokens or privacy pass and that it wants them from a client. It's an opportunity for a server or origin to indicate the types of tokens that it wants, like what, is this publicly verifiable? Is it using this algorithm or not? And it also can indicate who this origin trusts to issue tokens, like what keys is it going to validate against. And the last thing it does is that it does allow for interactive tokens. And this is something that I don't believe was captured previously in the protocols. But there are cases where you may not want to have a big bag of tokens that were previously cached, but origin may have a higher bar and say, I want you to prove right now that you're able to get a new token issued to you. All right, so what was missing in the landscape we had before? Because previously, as people have been testing with Privacy Pass, these functions have been running, but the previous design really relied on the JavaScript APIs as defined in W3C. It relied on them to actually drive this challenge and redemption functionality. There is an HTTP API document that we have, but it doesn't really give you the full scope here to be able to run this whole protocol. There wasn't any clear way that we could support new token types. So previously it was only defined to do POPRF, but we know that the working group does want to be able to support publicly verifiable tokens as well. So what we're proposing here is that, if you look at this interaction model of, oh, I have a challenge when a client tries to access a resource, and then I want to be able to provide a token, an authentication, it really, really fits cleanly into an HTTP authentication method. And defining that within this group, we believe will allow for a really nice standard definition that could have explicit support for different types of tokens, so we can have this be extensible and have it evolve. And this would work cleanly with the JavaScript APIs. There would need to be some updates to actually what those JavaScript APIs do, but they could just drive HTTP authentication very easily. But it also allows us to do this in non-JavaScript and non-web contexts. And in the discussions we've been having with people, beyond just web interactions, there are a lot of interactions of apps or other non-web scenarios that would really benefit from being able to use Privacy Pass. And it also has the benefit of having something we could define within the working group that can work standalone and then also be built on by the W3C. So the authors are proposing that this work that we're defining here can essentially replace the HTTP API document that we have and broaden it into this authentication method scheme. So the different features in this scheme are, it defines an IANA registry of token types, and these token types define what issuance protocol you want to use. And this is indicated within the challenge and the redemption phase. Chris will talk later about the different types, but essentially it'd be like, oh, there's the POPRF, there's a publicly verifiable option, etc. It also can indicate the issuer name and essentially say, oh, this is who I trust, or it can have multiple names of you can get tokens from any of these people. And it can also provide hints for the keys to use to make it faster for clients to get tokens without having to fetch some config from the side. And then it also has allows for some optional features which we think are very useful. One I already mentioned is an interactive token. Essentially, the challenge can come with a one-time nonce so that an origin can prove that the client was able to fetch a new token kind of inline, and this can avoid certain farming attacks. And then you can also just include within the elements that are signed on the token the actual origin name. And this can prevent cross-origin spending or attacks where you're trying to fingerprint what users have been going to, or one origin draining tokens that were meant to be better used on another origin as an optional thing you can add in. All right, so what is this? Oh yeah, the other thing we wanted to focus on here is we believe that it's really important if we want Privacy Pass to be widely used and adopted throughout the web and other servers, that it needs to be really, really easy for origins to adopt. When you look at the overall system for Privacy Pass, there is some complexity, but I think we believe that that complexity belongs more on the side of issuance and how do clients prove what they have. But on the side of just presenting a token to an origin, it should be really, really simple for that origin to do, so that many, many websites and origins can just adopt this and replace CAPTCHAs or replace other things they have. So as part of this, the origins don't need to do any complex crypto. They just need to verify tokens. For publicly verifiable types, like RSA blind signatures, that's really, really simple to do. Privately verifiable tokens do require the origin to have an issuer key or make a request to the issuer. That's what we have with the POPRF, but it's not too much to do in that case. But an origin can always choose to prefer the publicly verifiable type as well. And interactive tokens can also mitigate some concerns that origins had around farming and double spending and tracking that state. If you're using interactive tokens, you're shifting the state that's required on the origin from maintaining, oh, here's all of the redeemed tokens that I've had and making sure that no one's double spent, to instead just having a nonce that's associated with a single HTTP session with the client, and you just need to remember how many nonces did I give out, what were they, and that can be much, much more bounded. So the actual protocol details here, we're just proposing a private token HTTP authentication scheme that includes a challenge and a key that goes along with the challenge. The challenge is a structure that defines what token type it is, so it tells you what issuance protocol to use. It has a required issuer name, and it has an optional nonce and an optional origin name that can be covered by this. So if the redemption nonce is present, then you need to get a fresh token every time. If it's not present, you can use a cached token like you traditionally would with Privacy Pass today. If you have an origin name present, really that just is something that gets signed. And so if the origin name is present, you need a token that's specific to this origin, and you can't do cross-origin spending, but you can still cache it. Otherwise, if that's missing, it's just a generic token that can be used on any origin that supports cross-origin tokens. And the redemption side is also very simple. You just provide the token along with the scheme. That includes the same token type from one of the challenges. It includes a client-generated nonce that essentially makes the token unique. It includes a hash of the original challenge, and that's what makes sure that it covers the original challenge nonce or the origin name. It contains the key ID of the key that signs the token, and then has an authenticator, which would be a blob that's specific to the particular issuance method. That can be the blind RSA signature, it can be the POPRF output, or something else as we come up with better options into the future. And so, as long as you're using a valid issuance protocol, this does meet kind of the architectural requirement that this is unlinkable redemption. You can't link any two tokens back to the same client. And so overall, the proposal here would be to essentially adopt this document or replace the content of the existing HTTP API document with this definition of the HTTP auth scheme, and then move any of the HTTP interactions with issuers into an issuance protocol document, because we believe that can be iterated upon or swapped out for different issuance protocols in the future. And then the other piece of work we would need to do if we did this is, update some of the W3C API interaction. It doesn't necessarily need to change the API surface, just what it drives, to have it drive this HTTP auth method well. And that's all I have on this. Do we have any clarifying questions? Joe.
So basically, you're between the kind of this redemption protocol. You still have a linkage. There is a linkage between the issuer protocol and that you need to get a particular type of token, and exactly what the client does to prove that in that opaque blob is depends on that what happens during issuance, but the rest of the kind of the protocol shape is the same no matter what. That's kind of the idea.
That's right. And the idea is, today we already have, we'd already defined PRF. We want to bring in something like RSA blind signatures for public verifiability. So we need a way to tell between those. But even going forward, I think there are desires to have lighter weight publicly verifiable tokens. And it'd be nice to be able to use a common challenging redemption method and just have a bit to indicate, oh yeah, I also support this new token type that can do a blind signature that's publicly verifiable. We're going to support that as well. And so it allows us to evolve without having to rewrite origins completely every time.
Right. Thanks.
All right, Ben.
That's what, not as chair.
Yep.
So in previous iterations, one of the questions that has come up is about the privacy implications of timing-based linkability for these kinds of interactive issuance situations. So my first question is, what do you think of that? What do you think of the concern that that if an origin can tell me exactly when to request a new token, that the timing of that identifies the user?
Yeah, I think that certainly is, that can be a concern. The authors have discussed that as well. Generally, that's the type of thing that will be more mitigated for higher volume sites. Essentially cases where if you have millions of people always getting tokens, then you're not going to be able to use the timing attack there. I think it kind of folds, if I have very, very few people getting tokens with the place, even if I don't have a timing attack, you're probably able to guess pretty well who I am. It also plays into a little bit the interactions that we have on the issuance protocol and the role of, if we do separate out an attester, that a client who is coordinating with an attester, let's say, my iOS device talks to a server that can do device attestation, it could say, hey, no one else is using this issuer. It seems like maybe you're being fingerprinted here, as opposed to saying, oh yeah, I know that millions of people are actually going and hitting this all the time. You have a big enough anonymity set. But yeah, it's something to definitely continue discussing.
Yeah, I think that's interesting. I would point out that if you have an issuer with somewhere in the vicinity of, let's say, 100,000 active users, if those users all get a fresh batch of tokens once a day, then they have an anonymity set size of 100,000. But if they are in this interactive mode, then they essentially are fully identifiable because issuance presumably takes much less than 1 second. So,
Yeah, it depends how you do it. Yeah.
So anyway, I would like to see certainly some very clear analysis on that, and especially from the client's perspective, you know, are all these tokens, do all these tokens have the same privacy implications, and do we want to, you know, do we really want to provide
they
it?
don't.
And do we really want to provide a? So we've talked before about, for example, public metadata as something that can affect the privacy protection value of a token, but that's something that's very clear and measurable to the client. So it can do its own accounting for whether it wants to support that algorithm, for example.
Yeah.
I think that we need a little bit of thought into what the client's local policy is supposed to look like around these, around especially this interactive question, whether it can essentially budget for the amount of privacy loss that implies, or whether it actually is kind of unknowable to the client.
Yeah, I agree that'd be a good thing to add into here.
Thanks. I also wanted to specifically ask about the nonce. Is that nonce somehow blinded before it reaches the issuer?
Yes. Chris can talk about that a bit in the issuance protocol, I think.
Okay.
Too.
Thanks.
Yeah. Chris, did you have a comment?
Yeah, I just, Ben was asking for some analysis, but then what I think I just heard sort of come out of that conversation was that language around, you know, what the client doesn't know with respect to like how many other clients are happen to be using this issuer and at what time, is something that would be good to add. So Ben, I'm not sure like what analysis you had in mind beyond sort of just noting these considerations of the interactive protocol variants.
Well, so I should be clear. You know, I'm concerned that these interactive variants don't effectively provide significant privacy. That if we consider all of the other metadata visible to the other parties, that clients are actually effectively uniquely identifiable, even at quite large scales. I would like to see on the analysis side, can we, you know, make a convincing argument that the clients are strongly protected and show the sort of scale that's required there, and
So
and also can we talk about what we think clients should do to keep themselves well protected.
One other.
can I?
Sorry, go for it.
So my immediate reaction to that is that this is somewhat like, you know, the leaky boat problem that we kind of face in ECH. Like we are designing the protocol such that it's like cryptographically unlinkable between issuance and redemption. And yes, if there's additional metadata that's leaked, particularly around like the timestamps of these events, that you could stitch things together after the fact. But that seems sort of separate or external to the protocol that's sort of being defined here. One of the nice things about the redemption protocol that I don't recall you mentioning, Tommy, is that the clients have some leeway in terms of when they respond to a particular challenge. In fact, the HTTP header that carries the challenge has like a max age attribute, and the client can use that if it wanted to like delay things, to do all sorts of, you know, randomizing things. I'm using air quotes, but you can't see it, to sort of hide the timestamp to some extent, or to make it less correlated with what the origin sees. So I don't consider this to be a deal breaker any more than I would consider like leakage from IP addresses to be a deal breaker for ECH.
Thanks. That sounds like an example of something that should definitely be documented and again analyzed in terms of like how much delay is the recommended value. How should the client just make that decision?
Right.
I don't know if you can add recommendations here, though. That's kind of my point. Like the clients are in a position where they don't know how many other clients are interacting with a particular issue, and they don't know like what the value is. I think noting the considerations here is very much appropriate, but trying to offer recommendations for local client policy seems like an intractable problem to solve.
Yeah. So I know we're over time. I just want to chime in one more answer here. So I think this is another case where the architecture thinking about attester and issuer roles separately actually does help. So not only is it possible that an attester could help clients know about the scale, but I think more importantly, when you talk about a timing attack, we need to think about what is the information that is vulnerable and could be used to correlate information back to the client, right? So, if you think about a case where I talk to my origin over Tor and I'm hiding my IP address, but I talked to the issuer and I had to reveal something to it, like my actual IP address or my account or something that's more identifying, then that's really bad to have that linked back. But if we have deployments where the actual issuer that's handing out the tokens is more distanced from the client, such that it never sees the client IP, the client's going through it, another attester or something else, even if they do have some ability to guess with a small enough set that, oh yes, this is the same token as that other one, they may not actually learn much because the issuer may not know anything about the client. So that's another way that clients could get some protection here. And that's it.
Okay, thanks, Tommy, and thanks for the questions. So I'm going to now pivot over and talk about the issuance protocol that works in conjunction with the redemption protocol, and it sort of complements it in a way to produce tokens that satisfy a particular challenge from the origin. So this again is the scenario here. You have the origin that interacts with the client to send a challenge, and the client then on the side runs this issuance protocol to produce a matching token. So you can sort of view like the interface to the issuance protocol like so. Input from the origin, again, is just a public key that's used to verify the particular token. So in the case of the POPRF, it would be the public key. In the case of like blind RSA for the publicly verifiable variant, it would be the public key for blind RSA. And then the challenge, which is like this token challenge structure that Tommy was had on the slide earlier. And then the output from this is just an encoded token that the client then sends back to the origin. So basic issuance is really quite simple. I'm going to walk through sort of the cryptographic steps that like drive it. This is something that was in the existing protocol document, or steps of this were sort of in the existing protocol document, but we modified it to accommodate and integrate with the existing redemption protocol, or with the proposed redemption protocol rather. So anyways, the first thing the client does upon receiving this challenge is it generates a fresh nonce of its own, separately from whether or not the challenge carried a redemption nonce. And then it produces a context string or struct context value, which is effectively a hash of the challenge. And then from that point on, all it does is run basically the POPRF or the blind signature protocol over the pair of nonce and context values. So what I've written here is sort of notation that's specific to a blind signature protocol, specifically using the function blind with the public key of the issuer. But like you can imagine it being sort of any sort of suitable issuance protocol that matches that shape, where the inputs here, nonce and context, are private. They remain private from the issuer during the issuance flow, and the output that the client sees is like a valid signature or an authenticator, as was described earlier, over this private input. Okay, so generates the nonce, computes the context, and then starts the blind signature protocol. As per the blind signature protocol, after it computes its blind or request in this particular case, sends that over to the issuer, perhaps going through the attester if necessary for this particular deployment. Doesn't need to be though. The issuer then is an oracle for computing blind signatures over arbitrary requests. So it gets in a request, computes a blind signature, and then immediately sends the response back to the client. And the client simply finalizes the protocol to compute the authenticator. Pretty straightforward, very simple. And as I was saying earlier, I've written this in terms of the blind signature scheme, but this is in the basic issuance proposal that we have up. This is also implementable as a blind signature, or as a POPRF, sorry. One of the things that we've introduced with the new issuance protocol scheme is the notion of a token protocol or an issuance protocol type, and a corresponding registry to match, where the registry sort of defines the parameters of the issuance protocol, where a parameter might be whether or not it's publicly verifiable. That is, can you verify without having an authenticator, without having to interact with a particular issuer? Does it have support for public metadata? That is input or data that is revealed necessarily to the issuer in computing its half of the protocol. Or does it support private metadata? None of the proposed schemes in the registry right now do support private metadata, but there are some existing proposals from folks at Google for building anonymous issuance protocols with private metadata bits, individual bits. We could extend this registry to denote like how many bits of metadata are supported. So bike shedding here is necessary, but we feel like these are sort of reasonable dimensions and reasonable parameters for issuance protocols. And of course, the size of the authenticator, because that sort of defines the structure of the token that comes out of the other end. So right now in the basic issuance PR, we have two issuance protocols sort of just described that are in line with the redemption protocol. First of which is based on the POPRF work from the corresponding CFRG draft, instantiated with P384 and SHA-384. This particular curve was chosen because we didn't want to deal with the static Diffie-Hellman problem. So we just bumped up the curve a little bit to address that. And then we have blind RSA, which addresses the publicly verifiable component of the charter and is a drop-in replacement effectively for the POPRF, as described on the previous slide. And we can, certainly consider adding new issuance protocols to this registry as needed. So we could add the issuance protocols that support the private metadata bits, either the ones that are privately verifiable or publicly verifiable. There are proposals for each, and I don't know if there's CFRG drafts yet, but that's all that would be needed to sort of plug in here. We could also consider adding blind BLS. There is an existing CFRG draft for this, and work is underway to add blind support to that particular variant. An important point to note here is that these issuance protocols are only two messages or one round trip between client and issuer. There are constructions that are more than one round trip that require 3 or 4 messages, depending on the shape. Those would be compatible with the issuance protocol or with the architecture as described. Like the number of round trips is not really a constraint in terms of the architecture, because it's an implementation details specific to the issuance protocol. So I didn't list any of those here because there's concerns around how you would deploy this sort of thing, this type of issuance protocol with more than one round trip in a stateless way, or in a way that's safe, that has to deal with the state that the issuer maintains per client. But it is certainly possible. So there's a couple considerations that I wanted to note. The first is that the existing sort of, like I said, the existing sort of issuance protocols that we specified assume that the issuer is stateless. So it's one round trip for issuance protocols, but we could certainly move to protocols that support multiple round trips as necessary. Nothing prohibits that. Another thing to note is that the way that the issuer is interacted with, and in particular the APIs that are exposed by the issuer in order to interact with it, are compatible with any deployment-specific key consistency mechanism that would be desired for an application. So you can imagine like a service that pulls down issuer keys and throws them in a log somewhere, and then clients check that log. Whatever is appropriate for a particular use case or for an application. The point is that all the keys that the issuer might use are discoverable and via a well-known API, and then you can build things on top of that API to build consistency into the system. How that is done is out of scope. There's an individual draft that sort of describes different ways to address key consistency in the ecosystem. But we don't think that's that needs to be included in these drafts, more so that they need to accommodate any of these particular mechanisms if needed for a particular use case. Yeah, Ben, go ahead.
Clarifying question. You said that key consistency is out of scope. Are you noting that as out of scope for a particular draft or for the working group as a whole?
I think for these particular issuance protocols, like the issuance protocol should not address how to deal with issuance keys consistency. Rather, it should enable other work to address that as needed. So okay, I don't recall what the charter says on this particular topic. If it says that we need to address key consistency, that's cool. We could certainly write a separate draft that deals with it based on the issuance protocol that's described here. Yep. Okay. So in the architecture document, we describe various ideal security properties that we'd like for the issuance protocol. The most obvious one is this notion of unforgeability, where clients can't just forge tokens without having interacted with the issuer. And so all the issuance protocols as specified in the registry right now support this particular property. And indeed, this is a requirement to go in that registry. They also require that this notion of what we call issuance secrecy, and the description here is not the most clear, but issuance secrecy basically means that any of the input that is provided to the blind signature protocol or the issuance protocol generally is not revealed in any way to the issuer. So if you recall from the diagram earlier, we had this nonce and we had this context. Both of them are unconditionally secret, even against an all-powerful attacker who has like endless compute and endless memory and whatever. And this is necessary for the privacy and particularly the unlinkability guarantees that we have between issuance and redemption. Okay, so the proposal that we have at hand is to basically take what was currently described in the protocol document, which had bits and pieces of this. So it did have, some language around how to integrate with the POPRF. It did have some, details about how to do redemption, but nothing that was, implementable and interoperable. The proposal is to take the basic issuance protocol details and built upon the proposed redemption protocol and make that sort of the working group document protocol document. And there's a number of reasons to do so. It satisfies, perhaps I should have sorted these differently, but it satisfies the two requirements in the charter that we have public and private verifiability. It does integrate cleanly with the redemption protocol that Tommy presented. And it sort of it addresses this question of extensibility that has been floating around for at least a year now, I think. We were sort of tossing around different ways to address extensibility. Is it in like the wire format messages that are sent between client and issuer? Is it like how do you change the crypto and blah blah blah? But I think the current proposal where you wrap up all of the sort of issuance specific details under a token type and then introduce new types as necessary to extend the system with new, or extend the issuance protocol with new features, like rate limiting, as kind of we'll describe later if there's time. Is a very clean way to sort of address this with minimal complexity on the origin and on the issuer side. Like specifically, if you don't want to support any of these extensions, you just don't implement that token type protocol. Very simple. Okay. Before we go to the questions to the working group slide, I wanted to pause here and see if there's any questions. Okay, if not, I'll move forward then. So we just to kind of wrap up, there's a couple high-level questions we have for the group. First of which, are we want to know if the document proposals that presented specifically for the architecture document, the challenge and redemption protocol document, and then the basic issuance protocol document, are they clear? It's the sort of scope and sort of, does the scope make sense? Are the abstractions right? Are the considerations right, and so on? And then second, we want to know, or we want to try to assess if there's consensus to move in this direction, which specifically means updating the Privacy Pass architecture document based on the proposal at the beginning, as well as the protocol document based on the basic issuance protocol that I just walked through, as well as considering adoption of the new authentication scheme that describes the challenge redemption protocol that Tommy went through. And so I'm gonna stop sharing and I'm gonna turn it over. Or actually, I'll keep sharing, but I'll turn it over to the chairs. So I think this is where a discussion happens.
Hi, Ben Schwartz as chair. I would really appreciate hearing comments on these questions from the authors of the current adopted drafts. So if you're an author or if you're a co-author on a current adopted draft, I would really appreciate it if you would come to the mic and give us your thoughts. Thanks.
Hopefully you can hear me. Yeah, I think the restructure of the graph seems reasonable. I think there's a few issues to work out, like what information we put in the architecture doc, like the interactive timing. I think moving to the HTTP auth instead of the current HTTP API method, I think works well. I think there's going to be some questions about like cases where you need to trigger issuance redemption in ways that you don't necessarily have that like first leg. But I think that's all things we can edit within that specification. Overall seems reasonable.
Thanks, Alex.
Hi, yeah, Alex Davidson, Brave. So personally, as an author of both the architecture and protocol drafts, I think these proposals are clear and also moving forward in this direction makes sense. I think the one concern I have is around, as people have brought up previously, these interactive challenges and how we parameterize the privacy in the client privacy in those cases, because I think it could radically alter the anonymity set size for those clients, and that's something we tried to parameterize before. And if it's decided that we don't want to do that, then that may be reasonable. But I think the current parameterizations we have then are kind of redundant in that case.
Thanks, Alex. Chris?
I just wanted to say that I support the new direction, if that wasn't already obvious.
Thank you. Sophia?
Sophia Segui from Cloudflare. Yeah, I just wanted to say as well that I support the new directions. There seem to be some really small open questions, but I think we can discuss that further. And yeah, thank you for pushing forward all of this new direction.
Thank you. It seems like we've all the comments that we've heard have generally been positive and supportive of both updating these drafts and of adopting the new authorization draft. Does anybody want to provide an opinion going the other way? Okay, it seems like there isn't anybody speaking against these things. I haven't had a chance to confer with my co-chair. I would like to propose the following. It seems to me that the updates to the existing drafts can move forward without any further review by the working group. Of course, the contents of those drafts will be subject to many rounds of further review before it can exit the working group. And the new draft, I think it seems to me that the group needs some time to do a formal review for this before we do a call for adoption. So I don't think we're ready to trigger a call for adoption in this meeting, but I think we can do that very quickly if the draft is sent out to the list and people have a chance to read it. Then I think a call for adoption would be appropriate. Joe, what do you think?
I think, yeah, I agree. I think it's a fair thing to move forward with the changes and hold up on the adoption of the draft until we get kind of those things a little bit more settled and socialized in the group. But I think we're pretty good here.
Okay, Tommy?
All right. Yeah, thank you. So I think the order would be, because we haven't formally published the auth scheme as an ID, partly because it was referring to GitHub PRs that weren't merged. So I imagine, if we can merge those other PRs, then I can, once that's done, kind of get something with the right references published, send that to the list, and then we can discuss. And I think it sounds like the main open question that people have around that is, interactive, and how is that safe and when is that safe? I totally think that's what we should focus on going forward for the discussion. I want to hear to what degree people think, fully delving into that is required before adoption, or do we just kind of have a placeholder there of this is where you do it, and we need to agree as a working group when it's safe.
Thanks, Tommy. David Skenazy?
David Skenazy, Google. I was just had a process question for the chairs, because I've personally read the proposal, and I think it's definitely worth pursuing as a working group. If you're saying that we're not ready for adoption, what are we looking for? Obviously, we wouldn't decide in the room, but I'm not seeing any blockers to start the call. That will trigger people to actually read it.
So as Tommy pointed out, the draft formally doesn't exist yet. So we can't actually start a call for adoption until the draft exists. But I think I think Joe has more thoughts on this, so I'll hand it over to him.
Yeah, and I think also there's a little bit of an ordering dependency that we need to get the architecture draft updated before you can even update the auth scheme, and before, so that the references work out and all of that. So I think that's kind of the way the flow needs to be, but I could be wrong.
I would let there's a comment, but it seems like we can move forward on architecture without having all the drafts there. But I see Chris in the queue. All right, I'll leave my time. Thanks for clarifying.
Yeah, I just wanted to ask a clarifying question. So we can certainly merge the architecture, that's fine. But Ben also said that we could also move forward on the protocol document update. However, importantly, that depends on the redemption protocol document existing. In merging that change into the protocol document sort of assumes that this new redemption protocol will be a thing. So should we hold off on merging the protocol document change until there's been a consensus call on the authentication document, or I'm not sure what to do.
Does the protocol document rely on the specific details of the redemption document, or is it just we need to say that there's this thing that's going to exist, and we're that it's I mean, we're going to be in a chicken and egg problem, and I think I'd like to update the existing documents, and okay, there's going to be some dependency that one of them is going to depend on a draft that's yet to be adopted, but it seems like you could still evaluate some of the privacy protocol, and you can definitely evaluate the architectural changes somewhat independently of what exactly the auth scheme is.
I think we can, with a slight change of hand, just sort of remove the dependency on in the protocol document on the redemption protocol, and just say we get this challenge from space, or from carrier pigeon, whatever. That would be fine. So that would work.
Tommy?
Yeah, I agree with Chris that we could. I think it would be good to merge the protocol bits and just say, maybe even just reference, for example, it could be something like the mechanism described here, but not normatively depend on it yet. Just say, there is an issuance token type, there is some challenge blob, and then you need to send this back somewhere. But then we could always update it later to make it concrete.
Jana?
I was just going to propose that we treat at least the redemption protocol and the architecture documents as one bundle. So if you have any concerns about dependency and so on, because this is an adoption call, right? And ultimately, unless there's a good reason to separate them out, unless somebody's arguing that they ought to be separated out, could we just treat it as a bundle and see where that goes first?
So to be clear, are you proposing that none of these changes land until we've had a chance to do a formal, complete a formal adoption call for the authorization scheme?
I guess I'm suggesting that we see if there is pushback on that, right? If we try to do the architecture and the we can always split it off and say, okay, well, we can do this piece separately if there is pushback on it. But if there's not, then we avoid the whole conversation around dependencies and issues like that.
John, I'd rather not try to go down that road, because the reason we haven't published the auth scheme yet is we have nothing to reference yet that's in data tracker. So we'd have to come up with entirely new data tracker documents for everything.
All right.
Joe?
This kind of protocol with the attestation protocol, which is you know, it's not specifically, you know, a topic of this. You know, we're not going to define the attestation protocol here, but it seems like there are certain properties that it has to be able to carry certain sorts of information. And so that's something that, how well have we defined that yet in the architecture document? Chris or Jenna, is that?
Sorry, can you repeat that question?
Do we have a set of requirements for the attestation protocol?
No, that's and we're trying to keep that as much as possible out of scope. It's as Tommy was sort of describing, or John was describing earlier. That's a deployment specific question between client and trusted testers that will vary depending on the use case.
I mean, but it does have the section to describe, you know, what in broad strokes it does. So I think,
right,
Joe, your point is good, that you know, it needs to be clear of what the kind of minimum bar for what it does is. That can also vary depending on the specific type of issuance or deployment you're doing. Sometimes it's going to be a higher bar and sometimes it's not going to be.
Right. Okay. Thanks.
So in terms of direction moving forward, I want to just double check with Jana. Do you still think a sort of two-phase movement here is appropriate, or do you feel like we're probably better off trying to wait until we've done a call for adoption before making any of these changes?
I think Chris might have a plan. I'm going to let him respond.
Okay. Sorry, this is getting more complicated than it probably needs to be. So here's my proposal. We will, with the proposals of the redemption and the auth scheme document, we'll add some text and considerations around the sort of timing attacks or correlation that was brought up earlier. We will publish that in the data tracker. We'll merge the PRs outstanding against the architecture and protocol documents, which do cite this draft, and publish new versions of both of those. And then I think we can ask for an adoption call of the HTTP authentication draft.
Okay. Does anyone want to express concerns with that plan? Okay. Hearing none, I think we have a path forward. We have a few minutes remaining. Are there any other slides that the presenters wanted to cover?
There are more slides. There is not enough time to go through them. So I think we should just postpone that content for another time.
Okay. Joe, any closing thoughts?
Not specifically. I think I like this way forward, and we can schedule potentially another time, although I think we're getting close to the, I know, IETF time. I guess it's still a ways away. We can schedule another interim to go over additional material, if that makes sense.
Okay. Tommy?
Hey, regarding another meeting, we could probably just wait until 1:13, particularly if we do the adoption call in between. The reason I got in queue is one other thing I wanted to mention for people is that the various authors and people working on the new proposal
have also been doing implementations and interop testing. So Chris has a implementation, I think that's open source as well on GitHub that people could try out and test against that uses the HTTP auth method and the issuance protocol. So you can see how that looks as code. I've done an implementation for iOS and macOS as well that I've tested. And I believe some of the others are working on that. So if you're interested on trying this stuff out, we can also chat on the list or in GitHub or whatever. So just wanted to say, you know, we're committed to actually having running code here too.
Great. Okay, thanks for coming, everybody. That concludes our meeting of the Privacy Pass Working Group. I'll see you all at the next one. And thank you again to Matthew Finkel for being our note taker.
Thanks.